Yeah, hello from my side. I'm Anne-Sophie Saffert, and I'm here today with my colleague Jonas sitting there. We're coming from the OTH Regensburg in Germany, and we focus on the construction process simulation optimization with AI tools, with a special focus on a human-centered design, really towards the human and his health. Yeah, there are already existing solutions in construction, such as this masonry robot. Maybe some of you know this one. In this special example, the robot takes the load from the human. So it ensures a better health in the construction process. And that's a quite important topic I want to really emphasize. I brought a statistic here on the right, where you can see the construction industry is really at the top, indicating the sick leave days due to musculoskeletal disorders. Compared to the next two, it's the manufacturing industry and the agriculture industry, which is quite, physically demanding industry sectors. So yeah, with the construction industry on top, this is just a bit more. Which also has an influence on the shortage of skilled workers. I don't think that I have to emphasize this. I think you all know that construction industry faces these challenges. Therefore, we should do process planning appropriately to integrate assistive solutions like this masonry robot from the slide before, with a special focus to the human to evaluate how good can this robot fit into the process. Great. So the current state of this process simulation or process planning is that we first capture the process. We have methods such as motion capturing, that means recording the human motions and then transferring it to a digital human model. This can be done in an appropriate computer-aided process planning tool. We use the EMA Work Designer. It's special for working with human models and human movements. After setting up this digital twin of the human as well as the process environment, you can simulate this process and get results regarding, for example, the ergonomics. Here we use the so-called EAWS score, standing for Ergonomic Assessment Worksheet, and this is a standardized method for evaluation of the ergonomics in a process. According to the results, we then can change the process to in our case, more healthier process, as this is the parameter of interest. For example, we can, if you see the gray palette, we can move the brown palette to the gray position, or we can use other brick materials, like in this exemplary bricklaying use case. And then after this process adaptation, we simulate again and get, in best case, a better result for, in our case, the EAWS score. In detail, I brought you an exemplary process adaptation. Here on the left, we have the original process with an EAWS score of 87.5. And on the bottom, you can see the so-called spaghetti chart. That marks just the pathways the worker has been gone. When you change the material, this has a big influence on the EAWS score. For example, if you take lighter bricks, it's not that much load on the human as before, so the EAWS score reduces. When you then change the pallet position from originally here to here, this changes also the spaghetti chart, as the worker is doing a completely different walk path. And this has influence on the EAWS score as well. Yeah, mostly these processes I just showed you are made by hand and by human guesses. And we propose a conceptual framework where AI, which includes AI-based algorithms. So we don't have to do this manually, which is quite time-consuming, and we don't have to do these guesses by our own. On the left side, there's the original construction process, just as the bricklaying use case I just showed you. This can be represented parametrically digital by defining parameters such as the position of the pallet, the weight of the brick. If there's assistive technology, which robot does it support very, very high? Or is there a low support? Yeah, and when we have this part, okay, here are the examples. And after setting up, as we just discussed, we can execute the simulation, and then we get the results. You can see here the spaghetti chart as well, or the movement information of the human. And then we have our KPIs. In our case, it's the ergonomic criteria, but also the task or process duration, as well as the runways. The normal process optimization would be the dashed line with the circled one here in the mid. You normally, do this by hand, as mentioned, but here we have an adaptation of input parameters, these, using AI-based algorithms. Okay. And then this aims for a healthier ergonomic process design, which is also time improved and has enhanced walk paths. Speaking of algorithms, we used a genetic algorithm, the NSGA2 algorithm, which is special for handling a multitude of key performance indicators, such as our EAWS score, our duration, and the length of the walk paths. So how is it done in application? We first, on the left side, have the simulation software. That's the EMA work designer in our case. And this simulation software creates an object file, I would say. Yeah, maybe it's a little bit too small, but there on the left side, there are all objects contained in the simulation. And these objects have a multitude of properties which can be changed theoretically manually, but we include an automatic algorithm, so we can program hard code other properties. For example, we want to turn the brick from red to blue, so we can change it in this form. And then we can, then we can do the reverse. We import this changed file in the EMA work designer again, and then can simulate, and then we get the results. And then we can compare, is it better or is it worse? Challenge currently is that the EMA work designer and the coding environment there's no direct connection between. So this is a challenge which has to be focused in the future. It's really essential to have such an API as the need is there in industry. You also can expand the KPIs, not only EAWS score, depends on your preferences. It thematicizes the critical role of the human. The application in the construction industry is more in the prefabrication direction currently, but with this framework we propose, it's easier to do also on-site processes, as it can be calculated comparably very fast. And the last point is the algorithm requirements. The NS3A2 algorithm also needs a hyperparameter tuning and a selection of appropriate parameters to ensure the best result out of it. And with that, maybe the construction industry moves from manual processes to supported processes, for example, with the inclusion of more robots. Thank you for your attention. I'm happy to answer your questions.